Alright, for this video we are going to once again evaluate and graph a piecewise function, in this case this piecewise function. Now a piecewise function is in pieces, thus the name. This one is in 3 pieces, as you can see. Now the domain, which you can see here, I'm circling the domain. This tells you when to use which part of the piecewise function. All right, which x values you're going to be using which function. Okay, so these values that are in the parentheses, these are x values. So if x is 4, which one of these 3 situations are we in? Is 4 less than -1? No. Okay, is 4 between -1 and 4? No. All right, is 4 greater than or equal to 4? Well, yes, because of the equal to part. So for A, we're going to be using the green function, all right, because this domain tells us that we're going to use the third part of the piecewise function whenever the x values are greater than or equal to 4. And of course 4 is equal to 4, so we're going to use this. Now understand that this just says y equals 6. This is what this means. So anytime the x value is greater than or equal to 4, then y equals 6 automatically. So that means for this particular problem, we're just going to have a value of 6 every single time. Okay, what about for a value of 6, if an x value is 6? Okay, well, is that less than -1? No. Is it between -1 and 4? No. Is it greater than or equal to 4? Yes. So we're in the green situation once again. 6 is greater than 4. And again, anytime the x value is greater than or equal to 4, this is telling us that the value of the function will be 6. So this will be 6 once again. Okay, what about -8? Is -8 less than -1? Well, yes, it is. So that tells us that for C, we're in the blue situation. Okay, so for C, we're going to be using the top function, which says 2 times x plus 1. So we're going to be doing 2 times -8 plus 1. You could put this into a calculator if you need to, silly, but 2 times -8, that's -16, plus 1 is going to be -15. Okay, and what about the last one? Again, we have an x value of -1. Is -1 less than -1? No. Okay, is it between -1 and 4? Well, maybe. Let's see, we have to be more careful here. -1 is less than or equal to x, or x is less than 4. Well, because of the equal to part here, anytime that -1 is less than or equal to x, we're going to be doing the middle function. So because -1 is equal to -1, that tells us that we will be in the pink situation. Okay, and in the pink situation, we just do the opposite of x. So the opposite of -1 is +1. So that makes it pretty simple. So these are the 3 values that we're going to have. Okay, so we evaluated using the functions. Now we need to graph though. Okay, so remember what we have are 3 different equations. So I'm just going to write them separately. So it's like we have y equals in front of all of these. So this pink one, we have y equals -x. All right, that's the function that we're graphing. For the blue one, you should be thinking y equals 2x plus 1 as you look at this. And for the green one, you should be thinking y equals 6. Okay, let's just do these one at a time. So first of all, the blue one, y equals 2x plus 1. Now this is y equals mx plus b. This is a straight line. 1, this is not my best 1. Okay, that should be number 1. That's my y-intercept. Okay, so I'm going to put my first blue dot at 1. Okay, so I'm going to put a dot right there. Now, because the slope is 2, all right, you should be thinking 2 over 1. So I'm going to go up 2 and right 1 from here. So starting from my y-intercept, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, now I'm going to repeat the pattern in the opposite direction. So that would be down 2, back 1. So down 2, back 1, down 2, back 1, down 2, back 1, and so on, and so on, and so on. So these blue dots show me where this blue equation is. But I'm not going to keep the entire blue equation. I'm going to respect the domain. So I'm only going to keep the part of this graph where the x values are less than -1. I feel like I should zoom in. All right, again, I'm only going to use the blue function when the x values are less than -1. So let's look at the x-axis. Here's -1. So I'm only going to use the blue function when the x values are less than -1. So it's like I'm starting at -1 and I'm going to the left. Now I don't know why that just disappeared, but I'm going to draw it again. Okay, so these are the x values that we're dealing with. Now what about the point at -1 itself? Because I know I'm going to be using these blue dots over here to the left to guide me. But what about at the boundary point? Now what did it say again? It said less than, not equal to, just less than. So am I going to use a closed circle or an open circle here? An open circle, because it doesn't say or equal to. By contrast, the pink one, that's going to be a closed circle. See the or equal to line? See how the green one has a little line under it? I'm going to use a closed circle for the green one. But for the blue one, open circle. So at -1, at the boundary, I'm going to actually erase this dot here for a second. And so I can make that an open circle. Okay, so I've got an open circle here. And as you can see from the yellow highlighting, the domain says x values that are less than -1. So that's to the left. So that means I'm going to include all of these guys. So I will go ahead and draw this in because it's to the left. Okay, that just disappeared, didn't it? Okay, so that is the blue function. So that means all these blue points I have over here to the right, this is not part of the domain. All right, I'm only doing, it's only going to be the blue function when the x values are less than -1. These values are not, so I'm going to erase those. So I hope you're doing this in pencil because we're going to have some erasing to do. All right, I'm through with this yellow now, so I'm going to erase that as well. So we've done the blue function. Now I'm going to do the pink function. Now this pink function says y equals -x. All right, so understand me, people. This is like if I wanted to look at this as y equals mx plus b, it would be like negative 1x plus 0. So the pink function starts at 0. That would be my y-intercept. Okay, so it starts here at 0. Okay, now what? See that negative 1? That means I'm going to go down 1. And it's like down 1 over 1. I always go to the right. So I'm going to go down 1, right 1, like this. Down 1, right 1, down 1, right 1. Now I will also follow the same pattern to the left. Now you see how I'm beginning to overlap the blue? I know that I will fail the vertical line test if I start to go over here. So I'm not going to waste my time putting a bunch of dots over here. So I know I'm not going to go over into the blue area. So as I look at my domain, okay, this part right here, it tells me that I'm only going to use the pink function when the x values are between negative 1 and 4. So let's use our highlighter, x values from negative 1 to 4. All right, so this is the part of the graph where I will use the pink function between negative 1 and 4. So right away, I can erase any pink values that go past that. So here I am at negative 1, so that point's cool. These points are too far. Here I am at 4, okay, so that point is going to be useful. These points are gone. All right, it's only going to be the pink function between negative 1 and 4. So these pink dots, this one's at negative 1, this one's at 4. So these are the pink dots that show me where the pink function is going to be. Now, all I need to worry about is the endpoints. What about negative 1? What about 4? Well, look back at the domain very closely. At negative 1, it says less than or equal to. So that's going to be a closed circle at negative 1 because of the or equal to, but an open circle at 4 because not equal to. All right, I need to include the negative 1, but not include the 4. So closed circle, open circle. Okay, so this is already kind of a closed circle, but I'm going to make it more obvious. Okay, so there's my closed circle, and over here I'm going to do an open circle. Okay, and I will go ahead and connect these up. To show the pink part of the function. So there you go. I've got my blue function when the x values are less than negative 1. I have the pink function from negative 1 to 4. And what's left? All right, so I'm done with this. I'm going to erase that. So that just leaves the green function. Now, understand the green function, y equals 6. That is a constant. When I just have y equals a number, that is a horizontal line, straight across. A horizontal line at 6. Okay, so let me switch to green. So horizontal line at 6. So if I were doing dots, okay, here's 6 right here. A horizontal line at 6 would look like this. It'd be like boom, boom, boom. All right, this is a horizontal line at 6, which makes sense because these are all y values that equal 6. Y equals 6. Okay, but if I drew in this entire green line, I would miserably fail the vertical line test because here this is the pink zone. All right, I would fail the vertical line test here. Over here, this is the blue zone. I'd fail the vertical line test over here. So let's look at the domain so we can get this right. It's only going to be the green function for x values that are greater than or equal to 4. Let's use the highlighter. X values greater than or equal to 4. So here's 4. So I'm only going to be doing the green function to the right, greater than or equal to 4. okay, to the right. Okay, so here we are at 4, and we're going to the right. So I'm going to erase all of these points that are to the left. Okay, because this is the pink zone, this is the blue zone, erase all those. So here's where I'm going to have my green function. I just have to be careful about the borderline point here at 4. Will this be an open circle or a closed circle? Let's look again at the domain. Greater than or equal to 4, closed circle at 4. Okay, which is basically what I have, but I'm going to make it bolder and bigger and stronger. Kabam! Whoa, that is a bold point. All right, that's a magnificent point right there. And we're going to the right. As you can see, greater than or equal would be to the right. So I will be doing this right here. Okay, it shifted there at the end. That was unfortunate. Now I got to do it again. All right, so there you go. All right, so there's a green function. So let's zoom out. Let's get rid of this little guide situation. Let's zoom out and see what we've got here. All right, so here's an overall view of our piecewise function. Okay, we had the blue part, and then the pink part, and then the green part, based on which x values we're dealing with. Once again, notice I evaluated the function using the equations, but I also could evaluate them using the graph, couldn't I? Because look real quick. For A, it says look at an x value of 4. So check it out. Once I have my graph done, if I go to an x value of 4, and then I look to see where the function is. Well, if I look down, that's an open circle. That doesn't count. If I look up, I see it's at 6. So that's why the answer here is 6. What about at 6? Well, if I go to an x value of 6, I have to look up to get to the function, and that's at a y value of 6. So that's why, again, the answer is 6. Okay. What about negative 8? If I go to an x value of negative 8, then I have to look down to get to the function. Well, this is off the chart. Okay, so let's look and see. Well, it said negative 15, so that makes sense that that's off the grid. It only goes to negative 10. But let's look at negative 1. If I look at negative 1, then I'm right here. If I go down, that's an open circle. Forget about it. If I go up, here I am at the pink function. It's at a y value of 1, which is what I got by using the equation. So just two different ways to look at it. All right, so you can sort of use that as a way to double check yourself, right? If you use the equations and you got your values, you should graph the function and then look back. See if you get the same answers off of your graph. If you don't, you probably graphed it wrong.